Good morning. I am Teacher Anton. I'm here to help and to teach you how to solve math. My lesson is all about remainder theorem and factor theorem. From this picture, the girl is repack or transfer an egg from a bigger container to smaller containers. We may have extra pieces. In division, these extra pieces may be equivalent to when we divide a polynomial by a linear factor of the form x minus p is called divisor. We always get a constant r is called remainder. The division process stops when the degree of remainder is always less than the degree of divisor. In remainder theorem, if the polynomial f of x is divided by x minus p, the remainder is equals to f of p. This theorem is useful when we are interested in finding the remainder only without going through the process of long division or synthetic division. We just determine the value of f of p. From this remainder theorem, from this example, without using the long division or synthetic division, we can identify or determine the value of f of p as a remainder. For example, evaluate this equation. Now, from the remainder theorem, x is equals to 2. You just substitute from this equation f of 2 equals x to the power of 4 minus x to the power of 3 plus x to the power of 2 plus x minus 1. We need first to arrange the polynomial in descending order from the highest degree to the lowest degree of the variable. It is already arranged from descending order from raised to 4, raised to 3, and raised to 2, and raised to 1. Now, substitute the value of x from the variable x of the polynomials. 2 raised to 4 minus 2 raised to 3 plus 2 raised to 2 plus 2 minus 1. Two raised to 4 is equals to 16 minus 2 raised to 3, 8 plus 2 raised to 2, 4 plus 2 minus 1, 1. 12. 16 minus 8 plus 4 plus 1 equals 13. F of 2 is equals to 13, and 13 is called the remainder. Without using the long division or synthetic division, we can determine the value of f of p or the remainder by using the remainder theorem. In factor theorem, x minus p is factor of f of x if and only if f of p equal to 0. From the questions here, state whether a factor or not the divisor is a factor of the given polynomials. From the given polynomials here is 4x raised to 4 plus 6x raised to 3 plus 11x raised to 2 plus 29x minus 13. Divide x plus 5. How to find the value of x? You need to transpose by this divisor. X plus 5 equals x negative 5. Since the given is x plus 5, if you transpose the positive 5, it will change the sign of 5. So it will become negative 5. So now, first you will do is to identify the value of x. So you can substitute the variable from the value of x. F of x equals 4x raised to 4 plus 6x raised to 3 plus 11x raised to 2 plus 29x minus 13. Since x is equal to negative 5, substitute all the variable x to negative 5. F negative 5. 4 negative 5 raised to 4 plus 6 times negative 5 raised to 3 plus 11 times negative 5 raised to 2 plus 29 negative 5 raised to 1 or minus 13. From the parentheses, it represents as multiply by the coefficient 4. The exponent of the base from the negative 5. 4 negative 5 raised to 4 625 times plus negative 5 raised to 3 equals negative 125. 6 times negative 125. If the exponent is even, the result is always positive. If the exponent is odd, the result is always negative. Plus 11, negative 5 raised to 2. 2 is even, so the result is positive. Positive 25. Plus 29 times negative 5 equals negative 145. Minus 13. After you solve the exponent, then multiply. 4 times 625, 2,500. 6 times negative 125 equals negative 750. 11 or positive 11 times 25 equals positive 275. Negative 145 minus 13 is negative 158 equals F negative 5. 2,500 minus 750 1,750 plus 275 minus 158. F negative 5. 1,750 plus 275 minus 158 equals 1,867. From the result here, f of negative 5 equals 1,867. From the factor theorem, if x minus p is a factor if f of p is equals to 0. Since the result is not equals to 0, therefore, x plus 5 from the given is not a factor of the polynomials 4x raised to 4 plus 6x raised to 3 plus 11x raised to 2 plus 29x raised minus 13. Why is not a factor? It because f of p is not equal to 0. So x plus 5 is not a factor of the given polynomials. Another example. First you will do is the value of x equals x plus 1. Then transpose the constant positive 1 equals x negative 1. So the value of x is negative 1. F of x equals 3x 2017 plus x raised to 2010 plus 2x plus 4. Substitute the value of x, negative 1, 3 times negative 1 raised to 2017 plus negative 1 raised to 2010 plus 2 times negative 1 plus 4. F of negative 1 equals negative 1 raised to 2017. Since 17 is odd, the result is negative 1 plus negative 1 raised to 2010. 10 is even, so the result is positive 1 plus 2 times negative 1, negative 2 plus 4. F negative 1, 3 times negative 1, negative 3 plus 1 plus negative 2 plus 4. F negative 1, negative 3 plus 1, different sign, so subtract, becomes negative 2 plus 4, different sign, subtract, it becomes positive 2. Why? Because greater number follow the sign. Since the signs of 4 is positive, the result is positive. F negative 1 equals negative 2 plus 2, different sign, subtract, then it becomes 0. So the result is f of negative 1 equal to 0. Since f of p equals to 0, therefore x plus 1 is a factor of 3x raised to 20 17 plus x raised to 20 10 plus 2x plus 4.